Hello, in this video I will be covering the steps required to complete the deflection analysis of a span using CBeam. This step in our pre-engineering process is critical as it helps determine the system design strategy for the project. Let's begin by first taking a look at the deflection elevations we created for our Jumpstart Package 2. For this example, we will be using our SkyPoint Reno project. When looking at the elevations, you want to look for the tallest and widest span as our starting point. Now, once you find that span, using our Jumpstart tools in Bluebeam, we're going to highlight the span and insert a deflection analysis callout, like seen here. You will begin by entering the initial information for the callout. Enter the sequential CBeam tag and the part numbers you're going to analyze. We typically want to use our standard W75 system as our starting point for the systems unless noted in the Sales to Jumpstart kickoff meeting. Now, a quick tip. If you want to get another system to pass, notify sales in your Jumpstart 2 package to coordinate proposal details for bidding. These can be value-added options later on. So now that we've determined the system we want to use and the span we want to analyze, next we're going to open up the proposal drawings for the project to extract the parts section properties. To drop in a detail, you're going to want to grab it from the standard detail library and place it in the sandbox area. Typically, I like to create a copy of the part so I can work with the clear space. Now that our part is situated, we can use a section property command to extract the section properties from the part. The inertia and stress values we retrieve here will be used for our CBeam analysis in the next step. We can now go back into our deflection elevation and enter the rest of this information. And now it's finally time to open up CBeam. Once you open up CBeam, you're going to want to click on the white page to start a new project. For the project name, you want to use the CBeam tag. And for the test title, this will include the part number analyzed, the reference detail for the span, the type of zone, either corner or typical, the wind load used at that span, and finally the module width. The module width is half the width of the right light plus half the width of the left light. For this next part, we're going to reference our section view. We want to make note of the number of spans, the typical span length, and where our stack joint occurs. We can now enter this initial information into CBeam. To enter the uniform load, click on the calculator icon, then enter the required information. Now we can enter the section property values we got from AutoCAD. Once everything is filled out, we can click OK. You'll see that CBeam automatically creates anchors in between every span. To edit this, we can double click on the anchor and edit accordingly. We can also edit the span itself by double clicking on the span. This span needs to be 4 feet, so we will edit it accordingly. We also need to edit the parapet to match the architect's design intent. In our case, they have a wind load anchor 42 inches from the top. We need to reference our detail to double check. We will have to delete the current anchor we have for the parapet and add a new one. Since CBeam places our anchors as wind loads automatically, we will have to manually go and change them to dead load anchors at the slab. Next, we need to represent the stack joints as hinges. The hinge location is measured from the center of the check-in head to the center line of the anchor bolt. Refer to AutoCAD for a precise hinge location layout. For our example, the architect calls the stack joint to be 3 feet above the floor. Reference the section view for precise measurement. Another thing we need to edit is the wind load at the parapet. We will reference ASCE windload data from JS1. Our parapet windload in this case is 64.47 pounds a square foot. We are finally ready to analyze. To save the project, save as a CBeam tag number. Then you will be able to see the results. Once the results open up, you can enter any presets and relative information for this span. Once you are all set up, you can print to PDF. You now want to highlight the title name, the max deflection, and any other relative information. On the last page of the calculations, include a snippet of the part you analyzed. After that, you are now done with your CBeam analysis. Also, something to keep in mind, you can use special ASCE exceptions like taking tributary area pressures to reduce your loads if passing a particular system is absolutely required. If this is done, please notify sales and the structural engineer before kickoff. Thank you.